So here's another part of the video right now, and in this part we're talking about some quick questions. And here we are told that if x is a random variable capturing the number of heads in the toss of two fair coins, draw the probability distribution table and calculate the expected or the weighted mean, expected value or weighted mean. That is what that symbol here definitely represents. So let's take it into account very quickly. X is a random variable capturing the numbers of heads, okay, when you throw up two coins. Okay, good. Now here is a coin. I'm going to try to sketch out a coin here. Okay, so there's a coin. In a coin there are definitely going to be two part of a coin. I'm going to try to sketch this out. Okay, so that's a coin, and I'm going to try. Okay, so that we have it. Good. Now there are two parts to this coin which you're seeing here. It's going to have this side and the other side. Okay, it's going to have two video side, okay, which I'm going to be able to show you. I hope I'll be able to do that. Here, when you flip a coin, there is this side in the coin, there is this side of the coin, this side of the coin, which is called H. H represents the head, and there's this side of the coin which represent the T. We call that part the T, and that represent the tail. So there are two parts. So when you flip up this coin, and this coin which you're seeing here, and this coin is being tossed up, and you toss up this particular coin, okay, it's going to dance around. You guys know that, of course. The coin is going to be flipping around as you toss it. It's going to be rolling around. So it's either it land on this side or it land on the other side. So it's either the tail show or the head show, right? So it's going to be flipping around until that happen, right? So in that way, it's possible that the head show or the tail show. Now when you toss up, that is when you toss up just one coin. Is that not? When you toss up just one coin. But if you do this like two times, yeah, another thing can occur, right? So if you do this two times, there are a lot of things that can occur. When you toss up this coin once, it's either the things that can occur. What are the things that can occur? It's either the head will show or the tail will show. Either of these two happen. But if I toss up this coin two times, the same coin two times, then it's possible that the first time the head show and the second time the tail show, or the first time the tail show and the second time the head show, or the first time the tail show and the second time the tail show, or the first time head show and the second time another head show. You see here, these are all the variable things that can occur. All of these are the options. The options that can occur from that event. From that event, because tossing up this coin is definitely an event. Okay, so from that event, what are the things that can come up? It's either the first time I throw up the coin, head show, right? The head show, and the second time the tail show. Or the first time I toss it up, the tail show, and the second time the head show. Or the first time I toss it up, the tail show, and the next time the tail show. The second time again tail show. Or in the two toss, head show. So in that way, these are all. There's no any other thing that can happen again outside of this. So we predict everything that can happen in this event that I want to carry out. So you can think of it in this way. But in another way to think about it is to do this. Right? So let's think of it this way. Think about it like this now. That here on this side I have the I'm just going to call this an asterisk, okay? So here I have the head and the tail. That's like the first coin. I toss up 2 coin now. So when you toss up 1 coin 2 times, it's equivalent to just take 2 same coin and throwing it up once. It's the same thing. So I'm going to call this part the first coin. Okay, that is the first coin, and I'm going to put the second coin here. So that part, that is the second coin. Okay, that makes some sense, alas. So second coin. Okay, now I have 2 coin, 1 coin this way, 1 coin this way. So we carry out a variation distribution, and to do that, that will be head by head. That will give us head by tail. That will give us head, tail by head. That will give us tail by tail. That will give us tail. Now this is equivalent to the same thing I have here. Does that make sense here? Now I can do this again, which means if I take up 3 coin and I toss them together. Now what I will do is, this is the first coin and this is the second coin, right? So if I take up 3 coin and I toss it together, what will happen? So what will happen is, I will take this option here, which is 2 coin, and I will distribute it on 1 more coin, and that's going to be what you're going to see here. So I'm going to take up 2 coin. The 2 coin are head and tail and head, tail and tail. Then I will distribute it on 1 more coin. So this one is 2 coin, 1 more coin, and all of this together will give me 3 coin. So, and that means in this variation it will be head. You see that? And here will be head, tail, and here will be head, tail, head, and here will be head, tail, and tail, and then here will be tail, head, and head, and here will be tail, head, and tail, and here will be tail, and head, and here will be tail, and tail. So there we go. So this will give me the total distribution I'm going to get here. If you look at this and you count it all up, that'll be 1 2 3 4 5 6 7 8. So this is by 8. Total sample space is 8 in here, and here the total sample space here is 4. So they are 2 different. My total event, total options, total things that can happen here is 4, and total things that can happen here is how many? 8. Okay, I'll be looking into this too in a split of seconds. So let's get back to this question now. So we've created sample space right now for 2 fair coins that are thrown up, right? We have to draw the probability distribution table. So for us to draw the probability distribution table for this, we will have to do this. So let's do this. Okay, so we will get here. I'll try to make sure we have this perfectly. Now we will have definitely on this side x. What's our x capturing? We have to capture the number of heads, right? So the x, right, represent the number of heads. That's what our x represents, right? That's what the x represents. So here we have the x, we have the probability of x. Okay, so let's go ahead and solve this variable. We are capturing the number of heads. So to capture the number of heads, what we get here is definitely going to be here. The first time at this point here, right, you can definitely see that we are capturing the number of heads. So this is 2 heads, is that not? So 2 heads. The option that are very much possible is that we have 2 heads can occur, right? So we have 2 heads, right? We also have option for 1 head, is that not? And then we have option for what? 0 heads. So you see that is the option we have here. There is 2 head, 1 head, and no head. Those are the options. So that's the reason